October 14th, 1943. While the American public celebrated headlines of a production miracle, 30% of the U.S. industrial machine was already being processed as scrap metal. In a single training cycle for the P-47 Thunderbolt, a 7-ton flying liability, the U.S. Army Air Forces sanctioned the destruction of 41 aircraft and the deaths of 18 pilots before the group ever crossed the Atlantic. This wasn't a tragedy, it was the entry price for air superiority. The American war effort was never a polished engine of victory. It was a high-stakes, high-friction mechanical gamble operating on a 30% daily failure rate. We've been fed the narrative of tactical brilliance, but the forensic reality reveals an autopsy of an industrial tsunami, a system so volatile it consumed its own hardware faster than the enemy ever could. Before we dissect the wreckage, which technical specification of the P-47 Thunderbolt do you find most absurd for a fighter plane? Drop the stats in the comments. This is the story of two incompatible industrial philosophies, the German quality through scarcity versus the American victory through calculated waste. For the 1,850 veterans of the Africa Corps arriving in Mexia, Texas, the war didn't conclude with a surrender. It ended with a psychological demolition. While Germany had been forced into total blackout since 1940, these prisoners stepped off luxury Pullman coaches to find the Texas plains blaring with electric lights at 10 p.m. Nazi analysts had labeled this level of power output physically impossible. But the integrated machine possessed a brutal internal metabolism. To keep the river of material in motion, on the Red Ball Express required 300,000 gallons of fuel daily just to sustain its own heart, a technical liability that would have paralyzed any other nation on Earth. Through the 15-minute rule, where shattered trucks were cannibalized and abandoned in ditches, and an industrial arithmetic that viewed the loss of 60 bombers in a single day as acceptable overhead, the U.S. replaced 200 trucks daily, while the entire Luftwaffe lacked 200 planes to even begin an intercept. How did a system this mechanically unstable manage to bury the Third Reich under a mountain of strategic waste? The answer isn't in the battle plans, it's in the ledger. The American war effort did not begin with a victory parade, but with a staggering tally of metal and bone left on the training grounds of the continental United States. Before the first American boots hit the sand in North Africa, the domestic industrial machine was already operating at a catastrophic loss rate that would have bankrupted the military capacity of a lesser power. At the center of this systemic disaster was the Republic P-47 Thunderbolt, a 7-ton beast of chrome and steel that redefined the physical limits of aerial combat. This aircraft was not a nimble duelist. It was a flying brick of industrial overmatch, weighing twice as much as the German Messerschmitt Bf-109 when fully loaded. Its Pratt and Whitney R-2800 double Wasp engine, a 2,000 horsepower radial monster, demanded a fuel consumption rate of nearly 100 gallons per hour just to maintain a cruise, and far more during the high-stress maneuvers that characterized its early testing phase. The friction of this technology was immediate and lethal. For a single fighter group, the systemic cost of mastering this machine was 41 destroyed aircraft and the deaths of 18 pilots, all occurring in training accidents before a single enemy round was ever fired. The integrated machine was so volatile that it essentially consumed its own personnel as acceptable overhead to reach operational readiness. Ordnance units worked around the clock to manage a 30% daily mechanical failure rate that was treated as standard operating procedure. This was the high-tension reality, a system so powerful and so heavy that it was inherently dangerous to its own users. The P-47 was a technical liability that required a massive logistics tail just to keep its tires from bursting under its own immense weight, a weight that frequently exceeded 13,000 pounds when fueled and armed for a sortie. While German engineers focused on the tactical brilliance of lightweight, high-precision airframes, the American solution was to embrace the grind of systemic attrition. The industrial machine accepted that for every fighter that reached the front, several would be sacrificed to the friction of the training and ferry system. This was the fault line of the American doctrine. The belief that volume could overwhelm failure. The system didn't seek to eliminate training deaths or mechanical breakdowns. It sought to outproduce them. As the factories at Farmingdale and Evansville ramped up to produce a Thunderbolt roughly every hour, the logistics network was already bracing for the metabolic friction of the coming invasion, a demand for 300,000 gallons of fuel daily just to keep the internal supply lines from seizing up. The machine was breaking itself apart just to prove it could be rebuilt faster than the enemy could watch it fail. This was the arithmetic of a nation that viewed strategic waste as a weapon, setting the stage for the psychological collapse of the veterans who were about to witness this carelessness of infinite resource firsthand. The arrival of 1,850 veterans of Erwin Rommel's Africa Corps at Railroad Street in Mexia, Texas, marked a transition from the kinetic friction of the front to a systemic assault on their ideological foundations. These were the Wehrmacht's most experienced desert fighters, men who had operated under the extreme scarcity of the North African campaign, where every liter of fuel and every round of 88mm ammunition was tallied against a crumbling supply line. However, the moment they stepped down from cushioned Pullman coaches, they were confronted with a structural reality that Nazi analysts had categorized as a physical impossibility. A nation fighting a global war on two fronts while maintaining an absolute surplus of civilian infrastructure. In the Third Reich, blackout regulations had been a rigid necessity since 1940, plunging German industrial hubs into a darkness designed to mitigate the accuracy of Allied bombardiers. Even before the conflict, the German agricultural sector was a model of technical stagnation, and with rural electrification reaching barely 20% of farms. The prisoners had been indoctrinated to believe in the decadent collapse of American society, yet at 10 p.m. on the Texas plains, they witnessed an endless constellation of electricity that defied their internal maps of a warring world. Electric lights blazed from every farmhouse, street corner, and shop window, a display of power output that indicated the American integrated machine was producing energy at a volume that made the German rationing system look primitive. This was not a result of tactical brilliance, but the byproduct of a massive pre-war bureaucratic effort known as the Rural Electrification Act, which by 1943 had brought power to 90% of Texas farms. The contrast was a mechanical fault line. While German cities like Hamburg struggled with restricted current, A single American railway yard used more electricity in 1 hour than an entire district in Berlin consumed in a day. The prisoners documented this systemic shock in secret diaries, recording the carelessness of infinite resource, where lights were left burning in empty buildings and electric fans ran in vacant rooms. The systemic protagonist here was the American power grid, an infrastructure that allowed factories to run 3 shifts, 24 hours a day, 7 days a week, without the choking coal smoke that defined the Ruhr. The arrival of the POWs functioned as a triage for Nazi ideology. Every illuminated shop window at midnight acted as a data point that shattered 3 years of propaganda. It revealed that the American machine was not merely functioning, but was so secure in its industrial overmatch that it could afford to waste the very energy that Germany had been forced to hoard since the invasion of Poland. The first crack in the Nazi project was not a failure of will, but the realization that the mongrel nation possessed a metabolic capacity for production and consumption that rendered the racial purity of the Reich's scarcity-based model obsolete. The logistics of the Third Reich operated on a mechanical baseline known as the 40 and 8. Wooden freight wagons designed to hold either 40 men or 8 horses. This was the standard of the Wehrmacht, a system that prioritized the raw throughput of bodies across Europe with minimal caloric or environmental overhead. However, the American integrated machine responded to the arrival of enemy combatants with a different set of systemic protocols. At Norfolk Naval Base, the administrative processing of 30,000 prisoners per month was handled with a bureaucratic precision that included photographing identity cards, filing medical records, and administering inoculations in a conveyor belt fashion. The forensic transition occurred when these veterans were loaded not into boxcars, but into cushioned Pullman coaches equipped with dining services, sleeping berths, and silver cutlery. This was the opening volley in a bureaucratic war between Nazi ideological physical laws and American industrial reality. Nazi propaganda had consistently dismissed the United States as a mongrel nation of immigrants, predicting that a lack of racial purity would lead to a collapse of military and industrial discipline. The inconvenient truth encountered by the prisoners was that American strength flowed from industrial standardization, a system where a B-24 Liberator was assembled from 1,550,000 separate parts manufactured by 1,500 different subcontractors across 32 states. This level of modularity meant a shell manufactured in Ohio fit a gun in Michigan, served by a crew trained in Oklahoma, rendering the tactical brilliance of custom German engineering irrelevant. The systemic response to the heat of August was the provision of air conditioning, a luxury that German soldiers believed existed only on Hitler's personal train. This was not a gesture of heroism. It was a manifestation of the carelessness of infinite resource. The American logistics network assumed a staggering 30% daily mechanical failure rate as a normal cost of doing business, yet it possessed the metabolic capacity to maintain these luxury standards while simultaneously fueling a war on 2 fronts. To sustain this river of material, the system required 300,000 gallons of gasoline daily just to keep its internal heart beating, a technical liability that would have paralyzed the fuel-starved German high command. Supply lines showed no signs of collapse despite the massive overhead. The system intentionally prepared 10% more food than required, treating high-quality surplus as waste to ensure every prisoner received full rations of meat, white bread, and real coffee, items that had vanished from the German domestic market years prior. This luxury served as a triage for the prisoners' worldviews. The sight of ordinary laborers driving to work in private automobiles, while the promised people's car, or Volkswagen, remained a propaganda dream with fewer than 1,000 units delivered, shattered the assumption of American weakness. The Pullman car was the systemic protagonist of this chapter, a high-density data point proving that the American machine could lose more material in spillage than the entire Ruhr industrial region could produce at its peak. The operational reality of the European theater was governed by a brutal mechanical decay that the American integrated machine managed not through preservation, but through accelerated consumption. As Allied forces broke out from Normandy, the river of material was sustained by the Red Ball Express, a logistics system that functioned as a massive drug-fueled triage operation. The system demanded a fuel volume of 300,000 gallons of gasoline daily just to sustain its own internal heart, a metabolic requirement that exceeded the total fuel allocation for many entire German armies. Under this relentless pressure, the mechanical lifespan of a 2.5-ton deuce-and-a-half truck, normally rated for 30,000 miles, plummeted by 66% to just 10,000 miles. This was not a failure of engineering, but a calculated systemic choice to burn through hardware to maintain the velocity of the advance. At the field level, maintenance protocols were reduced to a binary of immediate utility. Mechanics and drivers operated under a strict 15-minute rule. If a vehicle suffered a mechanical failure on the route, the crew was allotted exactly 15 minutes to effect a repair. If the fault was not rectified within this window, the vehicle was not recovered. It was pushed into a ditch or stripped on the spot for critical parts to keep the remaining convoy in motion. This cannibalization was the only way the system could manage a 30% daily mechanical failure rate that command had integrated into its strategic calculus as normal. Supply lines showed constant signs of collapse, yet the industrial payoff was so vast that the U.S. could replace 200 trucks daily, a figure that dwarfed the total production capacity of the German automotive sector during the same period. The friction of this triage extended to the human and rubber components of the system. Tires were worn out by the thousands, and engines were frequently replaced weekly as drivers pushed the vehicles beyond their design limits. To sustain this pace, the system accepted a catastrophic loss rate characterizing the destruction of 5,000 trucks and the exhaustion of 23,000 men as acceptable overhead for the destruction of the German army in France. This was a war of arithmetic, where victory was achieved by an industrial machine that could lose more material in spillage and mechanical attrition than the entire Ruhr industrial region could produce at its peak. For the German observers, and this was the ultimate revelation of the carelessness of infinite resource, a nation so secure in its production capacity that it could afford to treat its own logistics network as a disposable asset. The integrated machine that delivered 150,000 men to the beaches of Normandy stalled within weeks against the earthen physics of the French bocage. The standard invasion doctrine, built on the assumption of rapid mechanized mobility, hit a systemic wall in the form of hedgerows, ancient earthen ramparts up to 15 feet thick that had solidified over 2 millennia. When the 30-ton M4 Sherman tanks attempted to scale these banks, they were forced into a nose-up attitude that exposed their thin underbelly armor to anti-tank fire, resulting in a localized failure rate that threatened to paralyze the Allied breakout. The official industrial response was hampered by a rigid design cycle that could not pivot fast enough to provide a factory-spec solution within the operational window. Survival of the system necessitated a decentralized, gritty triage that bypassed official command structures. Frontline ordnance units, facing a 30% daily mechanical failure rate across their vehicle fleets, began a process of systemic cannibalization. Sergeants harvested scrap metal from Rommel's asparagus, the massive steel beach obstacles like quintet elements and hedgehogs, and repurposed them into 15-foot steel teeth welded directly onto the tank hulls. This unapproved field modification transformed the Sherman from a climbing target into a cutting tool capable of shredding through earth and root alike. However, this grassroots success came with a stiff price in mechanical attrition. The addition of heavy scrap steel cutters increased the front-end load on the suspension, while the high-torque strain of breaching 2 millennia-old embankments accelerated the decay of the R975 radial engines. Logistics units, already struggling to provide the 300,000 gallons of fuel required daily for internal operations, were forced to replace power plants and transmission assemblies weekly. The 15-minute rule was applied with brutal efficiency. Any modified tank that suffered a mechanical seizure during a breach was immediately stripped of its cutters and parts to keep the river of material flowing. The system didn't seek a permanent engineering fix. It accepted the rapid wearing out of its armored assets as acceptable overhead for breaking the stalemate. The breakthrough was achieved not through a miracle of design, but through an industrial arithmetic that viewed the environment itself as a material to be overcome by sheer volume and cannibalized hardware. While the kinetic war was decided by the arithmetic of victory in the sky and on the road, the ideological war was finalized at the mess table. The American integrated machine utilized a systemic protocol known as the 10% surplus rule. This regulation mandated that camp kitchens prepare exactly 10% more food than required to guarantee that every prisoner received a full ration regardless of unforeseen logistical friction. To a German veteran who had subsisted on a standard allocation of 200 grams of meat per week, often reduced to near zero during the final months of the North African campaign, this surplus was not merely a comfort, it was a psychological siege. The system maintained a metabolic output that allowed for what prisoners described as magnificent waste. Aboard the Liberty ships, vessels produced at a peak rate of 3 per day, German soldiers watched American sailors dispose of half-eaten steaks, whole loaves of white bread, and gallons of milk that had simply exceeded their freshness window. This strategic waste was not a directed act of mockery, but a baseline systemic response to an overproduction of resources. The American machine was so calorie-dense that it consumed its own surplus as acceptable overhead, discarding perfectly viable food to maintain the efficiency of the river of material. The systemic reality of the American kitchen was a direct reflection of its industrial counterpart. Facilities like the Camp Hearn kitchen utilized electric mixers, automated dishwashers, and gas ranges capable of processing meals for 5,000 men simultaneously, a technological overmatch that mirrored the Willow Run plant's ability to assemble a B-24 Liberator every 63 minutes. Supply lines showed signs of localized collapse in the Reich, where the 200-gram meat ration was a theoretical maximum, while the American system moved food with the same carelessness of infinite resource it used to transport ammunition. The result was a widespread ideological collapse syndrome among the POWs. While witnessing American workers eating meat sandwiches during lunch breaks, consuming more protein in 15 minutes than a German laborer received in a week, shattered the Nazi myth of American industrial weakness and replaced it with the cold arithmetic of unavoidable defeat. The ideological collapse of the German High Command was not precipitated by a single tactical defeat, but by a forensic confrontation with American industrial arithmetic. By 1944, the integrated machine had achieved a production velocity that rendered traditional military attrition irrelevant. At the Ford Willow Run plant outside Detroit, a workforce of 42,000 personnel utilized 2.5 million square feet of floor space to produce a B-24 Liberator bomber every 63 minutes. This single facility consumed more electricity than the entire city of Cologne, and functioning as a systemic protagonist that generated an output of 1,550,000 individual parts per aircraft, coordinated across 1,500 subcontractors. For the German observers, many of whom were technical specialists like electrical engineers and chemists, the scale was incomprehensible. The technical fault line became most apparent in the sector of synthetic rubber production. Despite Germany having invented the chemical process, the Reich's industrial capacity peaked at a struggling 120,000 tons annually. In contrast, a single American site, the Rubbertown complex near Louisville, leveraged 4 massive facilities to produce 800,000 tons of synthetic rubber per year. These plants had transitioned from empty fields to full operational capacity in just 18 months, a rate of industrial expansion that bypassed the German model of incremental, precision-engineered growth. The American system accepted the stiff price of this rapid scaling, which included high mechanical failure rates in unproven catalytic crackers and distillation columns, yet the sheer volume of the industrial tsunami overwhelmed these systemic frictions. The friction of this overproduction was managed through a brutal triage of resources. While the Luftwaffe faced a localized collapse due to a total lack of 200 interceptor aircraft, American factories were replacing the loss of 60 heavy bombers in a single day, a 26% loss rate, within weeks. Logistics units and ordnance departments worked around the clock to manage the metabolic friction of this output, which required 300,000 gallons of fuel daily just to sustain the internal delivery of parts to the assembly lines. And the German realization was cold and objective. They were not fighting an army, but a self-sustaining industrial metabolism that could lose more material in spillage than the entire Ruhr region could manufacture at its peak. The arithmetic of victory was now written in the ledger of a nation that replaced its hardware faster than the laws of physics or the resistance of an enemy could destroy it. The final tally of the European theater reveals a victory calculated not in tactical maneuvers, but in the brutal ledger of acceptable overhead. By May 1945, the American industrial machine had completed its forensic demolition of the Third Reich by simply out-sustaining the laws of friction. General Eisenhower's Logistics Command admitted to a systemic cost that would have paralyzed any other warring power: the wearing out of 5,000 trucks and 23,000 men solely to maintain the momentum required to destroy the German army in France. This was the ultimate triage. The system did not seek to preserve its assets. It prioritized the velocity of the river of material over the mechanical lifespan of its hardware. The arithmetic of this victory was absolute. Throughout the campaign, the logistics network operated on a baseline assumption of a 30% daily mechanical failure rate. Yet the production tsunami was so vast that 200 replacement trucks were delivered to the front daily, a volume the Luftwaffe lacked the total airframe count to even begin to interdict. The systemic response to failure was always more volume. When the U.S. lost 60 bombers in a single day, a 26% loss rate on October 14, 1943, the factories replaced the entire fleet within weeks. This was strategic waste utilized as a weapon. The Americans demonstrated a capacity to lose more material in spillage and mechanical attrition than the entire Ruhr industrial region could produce at its peak. The 371,683 German POWs repatriated in 1946 carried this data back to a destroyed Germany. They had witnessed a system that required 300,000 gallons of fuel daily just to keep its internal heart beating, and they understood that their tactical brilliance had been rendered irrelevant by a nation that viewed catastrophic loss as a standard business expense. The 14 million man-days of agricultural labor and the 100 million board feet of lumber processed by these prisoners were merely subroutines in a larger metabolic process. Victory was not found in a miracle, but in the relentless output of an integrated machine that could afford to discard 10% of its caloric production as waste while its enemies starved. The ledger remains the most objective witness to the war's conclusion. A system that outproduced its own catastrophic failures until there was nothing left of the enemy to tally. History remembers the heroes, but the machines won the war.